Thank you. Hello. Hi. I actually speak a little bit of Chinese, but it's very bad, so I won't embarrass myself. Forgive me. So yeah, my name is Will. I'm from New York. Today I'm going to be talking about AMP and multithreaded JS. Big picture like this. Yes, I'm a software engineer at Google. I lead the AMP team in New York. We also have a team in California. And I work on supporting dynamic interactive experiences in AMP. And that's what I look like on a good day with Photoshop. All right, so what is AMP again? How many of you have heard of AMP? A little bit? No? Yes? We don't need to lie? It's okay. Thank you. Awesome. Some of you have heard of AMP, other people. So let's go over what is AMP. No. Let's see. So, picture okay. Some people think AMP is the key to getting traffic on Google search. Now, this is partly true, right? Because of some features on Google search, like top stories, only show AMP pages. And only AMP pages show the lightning bolt icon on Google search. The truth is actually that AMP does not affect ranking position of pages on Google search other than the top stories carousel. And AMP pages do appear on desktop as well as mobile search. So here's another perspective. Some people think this is Google's way of making web developers do what Google wants. Sometimes I feel like a little boy there too. And not everyone likes that. And I can understand why the belief exists. Why is Google messing with the web? Why doesn't Google just stick to search and messaging apps and leave the web alone? I don't know. Well, the reason is this. It's a loading icon, nothing actually shows. The problem is a lot of people are seeing this on the web. So, just a quick history lesson. AMP started about 3 years ago, 2015. And at that time, the web was in trouble. Websites were very slow and had bad user experience. Ads would pop up all over the place. What you're trying to read disappears because an ad has popped up over it. And native apps were taking over, right? Android and iOS. There were even people saying in blogs that the web is dead. Now, clearly the web hasn't died, and I'm very happy about that. I think you all know that. So why did Google get involved? Why did Google create AMP? The thing is, Google's business uniquely requires the web being vibrant and full of life. Because if you think about it, even if Google search is very fast, what good is it if all the websites you go to off of Google search look like that? Right? So let's take a closer look at how things are today. Some interesting statistics. Over half of users will leave a site if it takes longer than 3 seconds to load. I think I'm even more impatient than this, but it's interesting to keep in mind. The average mobile web page takes 19 seconds on 3G. 19 seconds. It's a long time. Yeah. And I know in Taiwan you guys have great 4G connections basically everywhere, even on the subway. Even on the J. We don't have that in here. I'm very jealous. But yes, this is actually a problem in many places. Yeah, 19 seconds, I'd be ready to take a nap as well. And actually, most of the mobile connections in the entire world are not even 3G. They're 2G. 60% of mobile connections in the world are 2G. It's very important for international networks. Now, another big part of the problem is the websites themselves, right? Not just users' connections. The average website has tripled in size over 6 years, from 2011 to 2017. This just means websites getting bigger and bigger, more and slower and longer to download. So this is why AMP was created, right? To help fix the problem of speed and poor user experience on the web, and try to make the web fast and user first. And it's an open source project, like many other popular ones, React, Angular. So what is AMP actually, besides 3 letters? You can think of it as being made of 3 parts. Right? So there's AMP HTML markup, which is basically HTML with some extra sauce on top. AMP JavaScript. So this is the runtime that does all of the special AMP performance improvements, right? Things like lazy loading, analytics, and other logic for AMP pages. And then there are AMP caches. So this is what AMP pages off of Google search are served from. And if a web crawler detects that your page is AMP, it will cache it and then serve it to users. Now, this has a few very important performance benefits, right? One is the cache is like a CDN, right? I mean, it is a CDN, which serves at a consistently fast speed to your users. And it also takes some of the burden off of your own web servers, which is very nice. Importantly, it allows instant loading through pre-rendering on Google search. What this means is that we actually will load the page in hidden iframe. That way, when the user taps, there's no network request that needs to be received before showing the page. Right? It's instant. We just show the iframe. So how does this happen? Well, there are many different reasons, but basically, AMP has some constraints, right? You can do a lot of very powerful stuff on the web today, but that's part of the issue why it's hard to make fast websites. So AMP was designed with the promise of efficiency and speed. And here are some constraints. The first one is no custom JS. Now I understand the irony of saying no JS at a JavaScript conference, but more on this in a second. Bear with me. The second one are restrictions on which HTML tags can be used. Right? So there's the special AMP HTML extension, and we wrap many standard HTML components to make sure that they have good user experience. One interesting example here is just the regular image tag, right? IMG. Super important, right? But the problem with IMG is it's not statically sized. That means if a user lands on your page and then fetches the image, it could cause your page to reflow and content to move around. So AMP image is a very simple wrapper around IMG to ensure that it has static layout, has good user experience. And third one is some limitations on the use and size of CSS. Now those are performance optimizations that I'll explain later. So the point of this is that, AMP has some constraints, but it also, to make up for it, gives you a lot of expressiveness and power out of the box with things like AMP components. This way you can still build, delightful but very performant websites on mobile and desktop. And for complex sites, you can still use components like AMP bind to write JavaScript-like expressions and use data binding for custom interactivity. And also, there are a few interesting exceptions to the Node.js rule, which I'll talk about later in this talk. Great, so yeah, there's a list of AMP components. So AMP components are web components. This is just another web standard. And these are built by not just Google engineers, but our large sort of external community on our open source GitHub project. You can think of these as like the Lego building blocks for AMP pages. And if there's not a existing Lego block that you're looking for, work with us to build it. Cool, so where is AMP today? Since its launch in 2015, AMP has been pretty widely adopted across the world. Publishers have created over 8 billion pages across 55 million domains, 230 countries, and more than 100 languages. I just read that on my laptop. But it's a lot of pages, a lot of websites using it today. And on average, about 90 AMP pages every second being released. So AMP started with things like static content like news and blogs, but has since developed features to support advanced use cases like e-commerce. And I want to talk about e-commerce for a second. Last year, half of all e-commerce revenue came from mobile. Pretty impressive. I didn't expect it to happen that quickly, but in today's world, mobile is super important, and this trend will likely continue. So here's the catch, right? Users want fast page load times, and right now they aren't fast. So that's bad for everyone. For every second of additional page load time, conversions drop by 7%. This is why for e-commerce in particular, the super fast page speed of AMP really makes a difference. In addition to e-commerce, AMP is seeing adoption in other verticals like food, travel, and other types of websites around the world. Just one example, so some real-world success. Wego is a Singaporean travel site. And it's the largest travel marketplace in the Middle East and Asia Pacific. Help people compare travel prices from local and global partners. So they created AMP versions of landing pages. So those are pages that users land off of search engines for queries like cheap flights from Singapore to Bangkok. And they found that conversion rates to partner sites went up nearly 100%, and search to conversion rates by half on AMP. Another success case study, Hua Taiwan, who I believe are here today, right? Built product pages, among others, in AMP for Yahoo Taiwan. And they're one of the top e-commerce retailers here. And we saw these increases in metrics, including bounce rate, more transactions, and revenue. One more, before we get bored. AliExpress, reducing load time by 36%, increased orders and conversion rates. So e-commerce, speed, important. And we're seeing, early success from many other partners too. But of course, we have a long way to go. Here's some videos. And one thing to note is that, AMP stands for Accelerated Mobile Pages. But AMP pages actually don't need to be only mobile. So here are some other ideas for the letter M. I like magical, so very magical pages. So full support for responsive design in AMP means that one AMP page can scale across mobile and desktop. And it works. So here's one example, is our actual project site, ampproject.org. All this, the entire site, is completely in AMP. And it's also completely responsive, scaling across desktop and mobile. One great example of mobile and desktop, besides our own website, is Tasty. They make those very addictive recipe videos that you see all over the place online. You can't stop watching them. And they actually use AMP to replace their original site entirely. Check them out, tasty.co. Cool. So I just said a lot of good things about AMP. Hope you believe me. Now some interesting things about how AMP is fast. Now I think there are some cool lessons that you can take out here, to your non-AMP pages as well. Many of these can also be found on best practice sites or tools like Lighthouse. Let's start with one of the simplest ways to speed up your page. Reduce the number of render blocking network requests, like external style sheets. If a user needs to download 5 different external style sheets before viewing a page, before the browser will render it, they're going to have a bad time. External style sheets also block font downloads, so doubly bad. So I'll use one of my favorite memes to highlight this. Any Drake fans? Right. Top is bad, bottom is good. Now everything has a trade-off, right? Now the trade-off here is that putting styles inline makes them not cacheable by the user agent, and it couples it to the content, right? So anytime you change the content, now the style is also not cacheable. Now that is a legitimate trade-off, and this won't make sense for every use case, but I think for most pages, this is actually a win. The good side effect here is it also encourages people developers to remove unused CSS. One big problem on the web that I hear a lot is it's very common to forget to remove old CSS for last year's Christmas special, for example. Yeah. Next one, lazy loading and resource prioritization. Now what this means is AMP runtime, this is part of the AMP.js, only downloads resources like images for things that the user actually sees, right? If I have a very long page, don't download the images at the bottom of the page. Resource prioritization means we prioritize user content over other resources like analytics or ads. That way the user always sees what they came for first, right? I don't have a good code snippet for that, so just a picture of Snorlax. If you see Snorlax, think lazy loading. Okay, it's because I like Pokemon. This one's a bit more complex. The way that browser rendering engines work is that when changing something like an element style property, it'll cause a layout invalidation. And then reading that property forces the browser to recompute, recalculate. So DOM reads and DOM writes should be batched together, reads with reads and writes with writes whenever possible. AMP's JavaScript runtime does this and tries to also minimize style recomputation. Something definitely to watch out for, and there are libraries like Fastdom that help you accomplish this. Chunking. Chunking is basically the process of splitting up expensive JS into pieces and then spreading them out over several frames. Now, why is this important? So imagine you have a piece of code, it takes a long time to run. Each of those blocks are one frame. The blue is long JavaScript. If this piece of code takes multiple frames, users won't be happy because it'll cause bad UX like stuttering and scroll stuttering and jank. Basically, the UI will be frozen for a few frames, right, while JavaScript's running. So, one way to solve this is to split it up into chunks and then spread them out. You can use APIs like request animation frame or request idle callback to do this. By spreading out the work over several frames, we don't have any frames that are frozen anymore. This ensures that your site is still smooth to scroll and users are happy. AMP does this in a few different places in AMP.js. So there are actually many other techniques that you can search online that AMP uses to make sure that AMP pages are fast and they stay fast. And the thing is, you can actually do all of these yourself, right? You don't need AMP to make a fast site. And I think it'd be awesome if you did. And tools like Lighthouse help. I think the main benefit of AMP is that there are a lot of things to remember to make a fast site. And it's very easy to mess up. So what AMP does is it packages all and serves it to you on a plate. And then you don't need to worry about applying 100 different performance techniques, right? I tried running Lighthouse on one of my sites and there was like 30 different things to look at. It's quite overwhelming. And I think even more difficult is worrying about performance regressions every time you add a new feature, right? This way, you can focus on building cool features and content for your users instead of worrying about performance all the time. That's what I do. Another benefit that AMP brings is browser support. So this is the bane of, or is what every web developer hates, right? Why doesn't this work in Safari? So we make sure that all AMP components have great cross-browser support for all popular browsers around the world. For example, we'll polyfill missing browser features when necessary, but we'll skip polyfills if they're very slow or heavy, or we'll use sort of a simpler version. Thinking about that a lot. Cool, so now hopefully you know a little bit about AMP and why it's fast, why it exists. You should all be thinking maybe, should I use AMP for my company or product? So, I mean, if you ask me, obviously I'll say yes, but I think, for web developers, there are a lot of tools and frameworks out there, and it can be a bit overwhelming, right? Don't get me wrong, these are all wonderful frameworks and they all have, great use cases. But how do you choose one? And where in this does AMP fit? So I think AMP, like other frameworks, they're a tool, right? It's not always better or worse. It depends on your use case and the trade-offs. Yeah, like I mentioned before, many developers spend many hours learning a new framework, mastering new technologies, spending hours on maintenance, and then even more making tweaks for performance. I think one of AMP's unique characteristics compared to other frameworks is that we really, really care about user experience. So it's a challenge balancing user experience versus developer experience. So I think if you find yourself working on a site where user experience could be better, And there are difficult trade-offs between user and developer experience, and might be able to help you. AMP can help because sometimes I think it's difficult to fight for the user experience, and AMP being opinionated and having constraints makes that decision simpler. So one example, right, is that AMP can be a political tool to fight back in the name of user experience. So maybe your manager says, hey, I really need a new analytics script in our website. And maybe it slows down the page by a few seconds. Well, you can easily say, nope, sorry, AMP doesn't allow it. So, and I'll be honest, right? Not all sites are suitable for AMP. Maybe you want to build the next Gmail or Google Maps, then I wouldn't use AMP, right? Maybe you want to build something like this. You know, actually, I think you can build this in AMP if you wanted to. I stole this slide from a colleague because I thought it was amazing. How cool is that? Yeah. Okay. Right, even though AMP has some constraints, it can really be used to build powerful, custom, interactive experiences. I mentioned the Amplifying Component before. You can think of it as a programming component, right? It draws inspiration from APIs from React and Angular and gives you a fast by default tool to build interactivity on your AMP pages. So I won't go into details of how this works. You can find more information online if you like. On the right is a AmpBind sample from ampbyexample.com. So back to the question, should I use AMP? We'd like you to adopt AMP because you care about your user experience. You know, and if AMP doesn't work for your use case, that's okay. You don't have to use it. If you want to build Gmail or Google Maps, AMP wouldn't be a great choice. But I encourage you guys to try it out. It might be easier than you think. Alrighty, next topic. Concurrency in JavaScript. I should talk faster. Right. Concurrency is a technical word for multiple parts of a computer program running at the same time. So if you have a computer phone or a phone that has more than one core, and it does, or if you have more than one computer, then this can make things get done faster. And it also generally makes things more complicated, unfortunately. Now, threads are important when talking about JavaScript. Threads can contain subprograms that run on your computer. More than one thread can be active at one time, hence multi-threaded. So with only one thread, a program can only do one thing at a given time on a given device. We call that single-threaded, right? So traditionally, web browsers only have one thread, the main thread, and your JavaScript runs on that thread. If your JavaScript runs and it runs and it runs, your browser can't do anything else. So that's not the case anymore, right? But it's still a good mental model for thinking about JavaScript on the web. So this is similar to our discussion on chunking. One number is the magic ideal for runtime performance. That's 60 frames per second. Here we have 1 second. So 60 FPS, or frames per second, is the refresh rate of most screens. Number of times your device's graphics card pushes new pixels to the screen per second. Movies run in 24 frames per second. But the human eye is very, very good at catching when frame rate dips or is inconsistent. And we want our web pages to run in 60 FPS. So 1 second, 60 frames. That means we have 16 milliseconds per frame to update the screen. Let's zoom in a bit. Well, it's not just your code that needs to run in 16 milliseconds, right? There's underlying systems, the browser itself, needing to layout changes, recalc styles, paint, composite layers, actually flip the pixels, and so on. So, and as a web developer, you actually can't control any of that, right? So one way to think about this is roughly split 16 in half as your budget. So this is an arbitrary number, right? It's not always half. Sometimes it's less, sometimes it's more. But it's easier to reason about. So 8 milliseconds, run JavaScript. Not a lot of time. Hopefully whatever we do is not very expensive. Let's zoom in more. Let's say you're running a JS framework like React or Angular. Typically, every frame you process events, right? User gestures, taps, swipes, things like that. Run some business logic, change state, figure out what to do, and then update the DOM again. And you have to make sure all of your code fits in 8 milliseconds. So maybe you work for days and days and you finally got everything smooth. You use chunking, right? Split out work across multiple frames. And it looks good on your own phone. Is that good enough? The problem is not all devices are created equal. As developers, I know this is true for me, we tend to like technology. We like to buy very nice, very expensive devices and have great network connections. And then we test our websites on these expensive devices and verify that, oh, the thing that I built works great. However, this means that maybe we're a little bit clueless on the experience for users without powerful devices or networks. So here's a concrete example. These are actually all brand new phones across a wide price range. At the bottom 15th percentile, we have a Nokia 2, which is brand new, can be bought today. 75th percentile, Pixel 2. And at the top, we have the iPhone 10 or X. Here is the chart of that performance for single core for those tiers I just mentioned. At the bottom, we see the Nokia 2 class of devices from 2011 to today. Hasn't changed that much. Those devices generally are becoming cheaper, not faster, right? So, and in the middle, we can see the green line. This is the 80th, 75th, 80th percentile price. Now, it starts at a similar point in 2011, but quickly diverges. So you can kind of see Moore's law take into effect, right? But the thing is, it really affects different devices on the price range differently. And at the top, right, those are basically the top, the new iPhones. So if you're testing your website on iPhones, you're really in a completely different world of performance compared to the 15th percentile users. So remember this performance gap. Next time you look and are testing your websites, try testing them on lower end networks and devices to make sure that we're not just testing the best with the best. That's the gap. Yeah, it's really that bad. And this guy is so upset, he's drinking beer and smoking cigarettes. Don't advise you do that. So turns out the graph for multi-core performance is very similar. Okay, so now we know that CPU performance varies a lot. So looks like we maybe need concurrency. How do we do it? Luckily, we have a hot new API to try out, web workers. Oh wait, actually, it's not very new. It's actually super old, almost 10 years old. Nonetheless, how do web workers help? Well, basically, you can push expensive data, logic, networking parts of your app to a background thread. How do they work in code? You create a worker with a URL to a worker script, and then you communicate via post message. Here you can see a sample for an input field. When I change the input field, I'll post a message to the worker with the value. Cool. Oh, where's the worker? There's the worker. So here you can see the worker receiving the value message in the onMessage handler, and then posting a message back to the main page. And voila! We have used the worker to offload the task of building a string. Now, there are a few problems with web workers. No access to the DOM, no shared state, and you can only communicate through post message. Now, I think this has something to do with the reason why it's 10 years old and not that much usage in the wild. They're not the easiest thing to use. This guy again, yeah. You feel like that? I feel like that every Monday. So how do I actually use web workers on my site? Yeah, so over the past year, we've been thinking the same thing, and we're experimenting with an interesting idea. Web workers have no DOM, and post message is a pain. What if we can render web apps entirely in the web worker, virtually? So we came up with this worker DOM idea. Put a virtual DOM in a web worker. So this is actually an open source library that's in alpha availability, which means don't use it in production yet. But it actually doesn't require AMP. So you can use this, experiment with it on your non-AMP pages. So remember this graphic. With a web worker, we can free up more of our 8 millisecond budget by pushing some stuff to the worker thread. Makes our lives a lot easier. So yeah, that's the power of worker DOM. Well, what about AMP? Well, we're working on bringing worker DOM into AMP with a new component. And we're calling it AMP script. It's still in development, but it's ready for experiments and prototyping. So we can quickly go over how it works. AMP pages ship with the AMP runtime. Runtime enforces things like static layout and lazy loading, right, Snorlax, and generally prevents components from having performance issues. So AMP components, AMP pages, that's fine. Now, if we want to add a React component to an AMP page, well, it doesn't really work. The React component lifecycle is not managed by the AMP runtime. React component might do a whole bunch of crazy stuff, right? Interleaving DOM reads and DOM writes, causing page jank. Yeah. So one component could be a bad actor, lowering the performance of the entire AMP page. What do we do? AMP script takes these components and places them in a security and performance sandbox, basically by throwing them onto a web worker. This allows the components to act more like AMP components managed by the AMP runtime, but still written in JavaScript. This works because the React component essentially lives in the web worker on a different thread, right? So, and worker DOM is the library that builds the communication between the web worker and the main page. And this is completely transparent to React, right? So you shouldn't need to make many changes in your React component to support this. Cool. So yeah, now with AmpScript, modern frameworks can operate within web workers and live inside AMP pages, and AMP runtime can observe and control the React component. So a couple of different phases, just interesting detail. Hydration. What this does is it takes the initial DOM state, right, what elements are there, and sends it from the page to the worker. We call this hydration. It's similar to server-side rendering hydration that you'll see in React, for example. And then inside the worker DOM, right, we have a custom mutation observer-like thing that listens to changes on the worker DOM. So when the React component re-renders and updates, right, the worker DOM will listen for those, send them back to the main page, which can make them real. Cool. So hopefully you've learned some new things about AMP and maybe some tips on how to make your web pages faster, and some interesting things about concurrency and multi-threaded JS. If you're interested in AMP, we are on GitHub. We also have some great documentation and resources available on the web. AMP by example is a good one. Great resource for learning and playing with all different types of AMP components. You can find detailed examples of documentation and complex samples that combine different AMP components together to build sort of complex use cases. For example, autocomplete on an input field. You can also check out AMP Start. It's a set of templates, kind of like what you'd see in Bootstrap, CSS. And it will get you started with beautiful visual design on your AMP pages. And as an open source project, we have an open development process with weekly public meetings for design review. And everyone is invited to attend over video conference, and you can give feedback on AMP designs. We actually have times that are, we rotate the design meeting times so that it's not always, middle of the night for one. Great, and we're also available all over various types of social media. We have a Slack channel. Here are some links if you want to take a screenshot. Cool, so I hope you found this helpful and have a slightly better understanding of AMP and some of the things that we're working on in the future. I'll be around to chat if you have any questions. Thank you.